It's pretty incredible when you stop and think about it. There's this constant, delicate balancing act happening every single second that keeps our planet from, well, either freezing solid or boiling over. We're going to dive into Earth's energy budget, that crucial flow of energy from the sun that literally makes all life here possible.
So why is our planet so, well, perfect for life? I mean, it's something we totally take for granted, right? Why aren't we a frozen rock like Mars or a crazy hot furnace like Venus? It all comes down to this really delicate dance of energy, a kind of planetary budget that has to be balanced just right.
And to really get a handle on this balance, we're going to follow the energy itself. We're going on its incredible 93 million-mile journey, all the way from the sun to us. And trust me, it's a journey with way more twists and turns than you might expect.
Okay, let's break it down like this. Imagine 100 units of solar energy leave the sun. Think of them like 100 cars starting a long road trip to Earth. Now you think they'd all make it, right? But here's the crazy part. Only 51 of those cars actually reach their final destination, the Earth's surface. So, what in the world happens to the other 49? Let's find out.
So the very first obstacle on this trip is reflection. A huge chunk of that solar energy gets, well, bounced at the border. It's like it gets turned away at the door, sent right back into space before it even gets a chance to warm us up.
All right, as soon as that energy hits the very edge of our atmosphere, bam! About 6 of our 100 little energy travelers get scattered by gases and dust. They're basically denied entry at the first checkpoint, so we're already down to 94. But the biggest roadblock? This one might actually surprise you. It's clouds. A whopping 20 units of energy gets stopped dead in their tracks by clouds. They act like these giant, fluffy mirrors in the sky, reflecting a massive chunk of sunlight right back where it came from.
And even for the energy that makes it past the atmosphere and the clouds, the journey still isn't over. Another 4 units get bounced away by the Earth's surface itself. We're talking mainly about the bright white areas, the huge ice sheets at the poles.
So let's do the math here. You've got 6% from the atmosphere, a huge 20% from clouds, and another 4% from the surface. Add that all up, and a full 30% of the sun's energy is just reflected away. It never even gets a chance to warm the planet.
There's actually a cool scientific term for this: albedo. It's really just a fancy word for how reflective a surface is. So bright things like clouds and ice, they have a high albedo. They're awesome at bouncing sunlight away.
Okay, so we figured out what happened to 30 of our energy units. They got reflected. But wait a minute, we were trying to figure out what happened to 49 of them, right? That leaves another 19 that are still missing in action. So where did they go? Well, they got absorbed by the atmosphere.
Now these 19 units are different. They aren't bounced back into space, but they still don't make it to the ground. Instead, they get soaked up, absorbed directly by stuff like water vapor, dust, and gases in the atmosphere. And when they get absorbed, they turn into heat, warming up the air itself.
So you can see the atmosphere takes a pretty big chunk for itself, that 19%. But the good news for us down here is that the majority, a full 51%, actually makes it through. It completes the journey and arrives at the Earth's surface.
And this is the main event. This is the energy that actually powers our entire world. After dodging all those obstacles and taking all those detours, this is the energy that finally arrives. 51%. Just think about that. After everything, over half of the sun's original energy is what gets absorbed by the land and the oceans. This is the stuff that really drives our planet. So what does this 51% actually do? Oh, just about everything. It's what warms our huge oceans and heats up the land. It's the engine that drives our weather. And, maybe most importantly, it's what powers photosynthesis, the absolute foundation of almost all life on Earth. And yeah, those dark surfaces, like big tropical rainforests, are super good at soaking this energy up. But hold on, the story doesn't end there, because if all that energy just stayed here, we'd have a big problem. For our planet to keep a stable temperature, all that absorbed energy can't just hang around. The Earth has to send it back out to complete the cycle.
And this is absolutely crucial. Think about it. If the Earth just kept soaking up that 51% day after day and never got rid of it, our planet would just get hotter and hotter and hotter. It would be a total runaway greenhouse effect. So, to stay in balance, it's simple. What comes in must go out.
So here's how that cycle completes. First, the warmed-up surface of the Earth sends that energy back out, but this time as heat. Most of that heat gets absorbed by the atmosphere, which then radiates it back out into space.
And just like that, the output perfectly balances the input, keeping everything nice and stable.
So let's just recap the whole budget one last time. We start with 100 units coming in from the sun. 30 get reflected straight away, the other 70 get absorbed, some by the air, most by the ground. And then, to keep things in balance, those exact same 70 units get sent back out to space. It's a perfectly balanced budget.
You know, for millennia, this energy budget has been the key to Earth's stability. It's what keeps our planet in that just right zone for life. The inputs have equaled the outputs. But that leaves us with one last, really big question. What happens if we start to tip those incredibly delicate scales?